Okay, the two buildings problem. So this is problem from the homework that we had, and there's not necessarily a trick to this, but there's one thing that you have to see what's not there. So if we go into this problem, it says two buildings of equal height are 760 feet apart. So I'm going to start that drawing like this. Okay, here are my two buildings. I'm not going to draw these out. There's no point, okay, because here's the edge of one of the buildings, here's the edge of the other building. They're 760 feet apart. An observer on the street between the buildings measures the angles of elevation to the tops of the buildings as 32 degrees and 42 degrees. So I'm not going to put the person directly in the middle. Because if I put the person, let's do it this way. If I put the person directly in the middle, okay, or as close to it as I can approximate, you look at this, these two angles are congruent, right? So you would have, since these two sides are the same, if I put it in the middle, you'd have two congruent triangles. So to mess with that a little bit, I'm going to move that person just off to the side. So my drawing is semi-accurate here. The higher degree of the angle, let's say the 42 degree angle, is over here, and the 32 degree angle is here. Okay, now the question is saying how high to the nearest foot are the buildings. So let's call that y because it's a measure of height, so we'll use y for this. This is the information that I have. This is the only information that I have. And this is a question where we know these two angles and this length, but none of these three lengths are a part of the same triangle, should we say. So when you go about doing this problem, you look at this, you're saying, oh, I'm going to find y, and I know this angle. Do you know this side length? Can we use right triangle trig with this side, and this angle? No, we don't know what that line of sight is. We don't know that distance. Do we know how far away the person is standing from the foot of the tower or the building? No, we don't know that either. This is the information that we know. So there's one thing here, and this is something that I hope you've learned up to this point, and that is when you're doing a problem like this with these angles of elevation or degree measurements or anything, you know, real world based, you're going to have to add to the drawing a little bit. Okay, so in other words, when I think I mentioned this at the beginning, you have to look at what's not there. And what's not there is if I draw that length right here connecting the tops of the two buildings, what is that length? That's the same as this. So that's 760 degrees, 760 feet. Now when we look at this, triangle, if we say that that distance is 760 feet, we can figure out what this angle is, right? These are supplements, so you add all those together, you get 106 degrees. Now what else do we know? This is flat ground. Since the height of these two towers or those two buildings is the same, we know that this segment is horizontal as well, which makes it parallel to this segment. Which means this angle acts as that side length acts as a transversal for these two parallel lines. We have parallel lines here. So if this is a 42 degree angle, this is a 42 degree angle. They're alternate interior angles. Similarly over here, if this is 32, then this is 32. Okay? So now when you look at the triangle that we've outlined in red, that's the triangle that you didn't have at the beginning of this problem. But with that one segment right here, now we've got this triangle where we know all three angles and we know one of the sides. So we have this angle opposite this side. If we set up a law of sines proportion here, 760 over the sine of 106 is equal to, we need side lengths here, so let's call this one x, let's call this one z. So I've got z across from 42 degrees, z over the sine of 42, and x over the sine of 32. Now, are those side lengths that I need? Is that what I'm solving for? No, I need to know what this is. But this side length here is not a part of this triangle, and this is the triangle that I know the most about. So that's the triangle, that's the key. Finding all of that information is going to help me because they do share this side. So if I can figure out what x is, then I'll know this side, I'll know this angle, and now I can use that right triangle trig to find y, right? So the setup to this, I hope this makes sense what you're looking at here. The rest of the way, it's pretty straightforward. If I set up a proportion using this and this ratio, I can solve for x. And I believe I went through and I did this already. So if we solve that, we get, let's see, what do I have, 418. This side length ends up being 418.97. And then if we, like I showed you before, if we use this right triangle, we can solve for the height. Now I don't need to know z, but if I found z, I would have used this right triangle to solve for that height. They're the same height, so it doesn't matter which one I use. Okay, so now that I have this side length, I can use this angle and a sine ratio to solve for y. So what would that look like? That would be the sine of 42 is equal to the opposite side over this hypotenuse 418.97. Okay, type that into your calculator, and I believe we get y is approximately 280.3